All right, so we're on part 2 of section 1.1. So this is how to determine if it's truly a function. So verbally, can any specific input correspond to more than one output? If not, then it is a function. Numerically, to determine if a table of data represents a function, we have to decide whether each input produces exactly one output. So sometimes your table might say, your input values is x is equal to 5, but your output might be a range. It might be between, 30 and 45 or something like that. So if it's a range, then that's not going to give you a function. But if it gives you one input, gives you one output, then it will be. Graphically, we can use a vertical line test. That's the nice one. And so basically, if a vertical line drawn through the graph does not cross the graph more than once, it's a function. But if it crosses more than once, like a circle, it'll hit twice as you do a vertical line, then it's not going to be a function. And algebraically, for a function represented as an equation, what we're going to do is we're going to substitute the value of the input into the equation and solve. If the input gives us exactly one output, then it is a function. If not, then it's not going to be a function. So let's look at some examples. And so what we want to do is we want to identify the representation of the relation as numerical, algebraic, verbal, or graphical. Then we want to state the description and units of measure for both input and output variables. And then we want to indicate whether the relation is a function or not. All right, so for part A, well, all we have to do is we're going to say, what is this? Well, since this is a table, that would be numerical. So A is going to be numerical. B, state the description and units of measure. Okay, so the input is going to be the loaf diameter, and it's in D, and it's going to be in inches. That's going to be the unit. And then the output is going to be baking time, and that's with a T, and that's going to be in minutes. Okay. Now C, is it a function or not? Well, one input gives a whole range of outputs. And so though it does give you some range of them, it's not just a single one. So no, not a function. Now, if it had given us a 1.5 inch diameter loaf, gives a baking time of 45 minutes exactly, then yes, you're done. And it would be a function. But since baking is kind of a thing where it could be a range depending on altitude, temperature, things like that, then we have this range of times, and so that one's not a function. Okay, military pay. All right, so what is this one? Well, it's a table again, so it's numerical. And a lot of times, those are the easy ones to kind of see what they are. Now, what are the input? Well, the input is the rank, okay? And what are the units? Well, there's really not a unit. It's just a rank. So, so no specific units, okay? Now, the output is going to be your pay, and we had that as P, and this was the rank in R. And so this one is actually units of dollars, okay? Now, is it a function? Well, one input gives us exactly one output. And so every one of these is a one-to-one. So this is a function. Okay, so we do have a function here. What about this one? iPod sales. So it says this figure shows iPod sales between 2002 and 2008. So A, well, this is going to be a graphical because we have a graph. And B, what is our input? Remember, those are the X's. And so this is going to be input is going to be years since 2000. And output, oh, and that's just going to be the units are going to be years, or number, or just a number, I guess. It's not really years. It's just a number. How do we want to say that? Years since. I guess that would be the unit, years. And the output is going to be thousands of iPods. and the units are just the numerical numbers. Okay. And see, is it a function or not? Well, if we look here, while it doesn't have a nice line drawn, as good as I can draw a line here, it looks like that to me. And no matter how many times I draw a vertical line here, I'm only going to cross it one time. And so in this case, I would say that this is a function. All right, geometry. So it says an equation y equals plus or minus the square root of 36 minus x squared is the coordinate for a point with x coordinate between -6 and +6 on a circle with a radius of 6 centimeters centered at the origin. All right, well, this is going to be algebraic because we have this equation. It's an algebraic equation. Now, B, what is the input? Well, that's going to be the x coordinate. And it's going to be some number between negatives and 6 and 6. So, and it's centimeters. So we can say it's in the x coordinate is in units of centimeters, and the output is going to be the y coordinate, and it's also going to be a unit of centimeters. Okay, so it's going to be some kind of a centimeters. Now, is it a function? Well, what did it say? It's a circle, really. And we have this circle. And so it's kind of drawn right in the center like this. So we have, this is a radius 6. And so it's going -6 here, +6 here, +6 here, -6 here. And so we have the 4 different corners. But any line we draw, it crosses there. So it's not a function. Okay. And here, number 5, what do we have? A. Well, the P relationship P gives the price of a certain book, X, purchased through Amazon.com. Prices in dollars. Well, this is going to be a verbal. It's just telling us everything's written out. We can make an equation out of it, but it's a verbal way it's written in this term. And so P gives the price of a certain book. X is purchased through Amazon.com. So our price is P. So that's going to be our input. All right, so our input. Oh wait, the book title actually is going to be your input, because depending on which book you get depends on which price you pay. So input is actually the title of the book. Sorry, have to look at this a different way because it's not an equation, it's not a graph, so you have to really think about what it is. And your output is the price paid. Now C, is it a function? Well, if you were looking at a specific website like some specific bookstore, yeah, it probably would be a function. But what do we know about Amazon.com? Well, Amazon.com, there are hundreds of sellers now, the way it's set up. And so, seller A might be, it's $14.95 plus shipping, and seller B might be $15.60 with shipping. Seller D might be $20 and no shipping charge. And so there's no single price here. So this won't be a function because one input of whatever the title is can give you multiple prices for the output. And so because of that, it's not a function. And again, depending on what you're looking at here, as far as, if we were looking at one bookstore, they only sold it and it was going to be that price, then if it was only sold in paperback, we would have it. But if we had the possibility of paperback versus hardback, you're back to the same title, giving two prices, because your paperback's going to be one price a lot cheaper than the hardback being a higher price. So you really have to think about what they're giving you and how that can be and what it is, if it's going to be a function or not. All right, so these are going to be the easy ones. Determine whether the relationship graph below is a function or not. So all we have to do is do a vertical line test. No matter how many times we do that one, yes, that's a function. This one, same thing. No matter how many times we do it, it is a function. No matter how many times we do this one, the only time it would have one spot was when we went tangent to it there, but anywhere else, it's going to cut it and it's not going to be a function, okay? All right, so that's all I have for section 1.1.